In the previous video, we looked at why some isotopes are radioactive and why they decay, and we learned that when the strong nuclear force is not as strong as the repulsive force, that the nucleus will decay, and that means it's going to emit something which will allow it to be more stable and have a lower energy. And what it emits is the topic of this video. There's three different types of radioactive decay. The first type we're going to look at is called alpha decay, and that's when an alpha particle gets emitted. What is an alpha particle? It's the same thing as a helium nucleus. So it's 2 protons and 2 neutrons, which would give it a mass of 4, and no electrons. It's just the helium nucleus. So here's an image showing a decay. Notice that the mass of the nucleus drops by 4. The atomic number also drops by 2 because we're losing 2 protons. We're going to look at another example here. We'll look at uranium-238. Uranium has an atomic number of 92, and if it decays by alpha decay, that means a helium nucleus will be emitted. And what is left over? Well, when you're writing these equations, these are called nuclear equations. They're similar to the chemical equations you did, except that in this case, new elements are often being produced. When we write these, we need to conserve the mass. That means whatever the mass on the reactant side, we want to make sure we have it on the product side as well. So if it's 238 on the reactant side and helium is 4, whatever we're going to put here is going to have a mass of 234. We also have to conserve the charge. So if this is 92, that's the atomic number. Remember, that means 92 protons or 92 positive charges. We've got 2 positive charges here with the helium, so we're going to need 90 to be the number of protons here. So then you would look at your periodic table, find atomic number 90, and you can see that it's thorium. So we've just written the nuclear equation for the alpha decay of uranium-238. In the next example, we're going to look at beta decay. So in beta decay, a beta particle is emitted. Notice that this is also a particle. We've seen alpha particles, this is a beta particle. In this case, a beta particle is a high energy electron. So if we look at an example, we'll look at carbon-14. There's carbon-14, and if it decays by beta decay, that means an electron is going to be emitted. Now the mass of an electron, although it does have mass, it's so small compared to protons and neutrons that we can just say its mass is 0. The charge of an electron, as you know, is negative, and if it's 1 electron we're drawing here, we'll say -1. So what else is going to be produced here? Well, the mass needs to be 14 to conserve the mass, and if we want to conserve the charge as well, -1 plus some number has to give us 6. Well, this has to be a 7. So we look at your periodic table, see what atomic number 7 is, and you'll see that it's nitrogen. So we've learned that carbon-14 decays by beta decay into nitrogen-14. Okay, now where did that electron come from? Well, if you notice, the mass hasn't changed, but the atomic number has gone up by 1. So what happened is one of the neutrons turned into a proton and an electron.